Okay, this is lesson 28, which is a continuation of the last lesson, but in this lesson we're going to model two variable problems and model into algebraic equations and solve using algebra. To solve for multiple variable problems, you must have the same number of equations as you do unknowns. That means for a two variable problem, we will need two separate different equations. Okay, and here's our problem. You are the owner of a traveling circus charging for attendance $3.50 per child and $7 per adult. In Kansas City, the total revenue from attendance was $10,199, and from the turnstile count, you know that 2,200 people total attended. How many were adults and how many were children? Okay, and I'm going to bring back the 5 steps we saw in lesson 27, the 5 steps used in modeling and solving problems. Okay, we saw these in the last lesson, and this time we do see step 2, which was not applicable in a single variable problem. But going over them again, start over. Okay, so these are the 5 steps. We saw 4 of them in the last lesson. Here we include step 2 that says to represent the other unknowns in terms of x. So in other words, this is applying to multiple unknowns and multiple equation problems. All right, so starting with step 1, we've read the problem, we understand the problem. We're going to let x, actually we're not going to use x, we're going to use a and c, because what we're wanting to know is from the problem we know that we're trying to solve for the number of adults and we want to solve for the number of children that attended. These are our two unknowns, and we could have let them x and y, but to me, A for adults, C for children makes more sense. So we will use A and C. Okay, so our first equation, we know there were a total of 2,200 people. So that includes the adults and the children. So our first equation is A plus C, adults plus the number of children, equals 2,200. Second equation stems from this known here. Total revenue from attendance was $10,199, and we know that we charge $7 for each adult and $3.50 for each child. So to rewrite that, we could say $7 per adult times the number of adults plus $3.50 per child times the number of children equals $10,199. Okay, and note that step 2 says to put our other unknowns in terms of our first unknown. This states x, but instead of using x, we used a. So in other words, it's saying put the C unknown, children, in terms of a. What does that really mean? It's basically just substituting. What does that mean? Well, let's work with this equation here and put it in terms, and solve for C, but we will put it in terms of A. All right, so this is in terms of A now. So there is our second equation. And our first equation here. And in this method of solving the problem, we're going to use the substitution method. So we're going to substitute this C into this equation here. I'm going to clean the slate and rewrite this. And again, this method is called solving by substitution. And basically we substitute this value of C in the first equation. Note that this value of C came down into the first equation. And so expanding out, we can rewrite it. And grouping alike terms. This goes to negative A plus 2914 equals 2200. And so we have and multiplying both sides times negative 1, we have, so the number of adults is 714. Now we can plug this value in to our first equation here and solve for C. So we have 1,486 children. Recall the last step is to go back and verify that these values are correct. So we will use the first equation, the number of adults plus the number of children should equal 2,200. And if we plug that into that is true. And let's try the other known information. And that is that $7 times the number of adults plus $3.50 times the number of children that should equal 10,199. And plugging that into the calculator, we see that it does equal. So we know that our values are correct. So again, number of children is 1,486. Number of adults is 714. And that, again, is solving by substitution, which implies there's other ways to solve for these. And indeed there are. The other two ways are solving by graphing the two equations and where they intersect is your answer, and also solving by using systems of equations. And I will address both of those in the next two lessons.